Hey there, good morning. How are y'all doing? So my name's Dan Zentgraf. I'm up out of Austin, Texas. I'm a solutions architect with a company called Datical. Been involved with the DevOps movement since before we had the buzzword and all that good stuff. One of the organizers for DevOpsDays Austin. We just had our 8th event back in May. And as an organizer, I can tell you that the organizers, volunteers, and sponsors, everybody who's putting this stuff on are working their butts off to give us this awesome event here today. Be sure and take a couple of minutes to thank them and show your appreciation. It's well appreciated. Alrighty, so here to talk about the database thing, that forgotten bit of DevOps. So in this talk today, what I'm going to do is I'm going to talk primarily about relational databases. It's not that NoSQL databases aren't kind of their own bucket of fun, but I primarily work the enterprise beat, where the vast majority of data is still in relational databases, right? And talk a little bit about the blocking factors. What's keeping databases outside of our CI/CD flows? Talk a little bit about what database change management really is, what it actually looks like, and finally, what it takes to bolt these beasts into a CI/CD flow. All right? So the interesting thing about this is that at the core of this, it's a change management problem. And it's not that database change management tools haven't been out there for a long time, right? I mean, you know, the CD community's been aware of this for a while, right? I mean, there are 3 pages, 3, that mention databases in the continuous delivery book by Jez Humble. You know, book. 3 pages. I mean, personally, I was involved in a product. We were trying to figure out how to do better deployments of things back when CI was a commercial thing and kind of before Hudson even existed. I was involved with that, and we were trying to figure out how to deploy this stuff we were building so that we could do better tests and faster. And we talked about all the things we had to integrate with, and we put databases on that list at the bottom of the list because it looked freaking hard. But imagine my surprise that, you know, 12 years later, I'm up here talking about this as the forgotten or hidden piece of the CI/CD puzzle, right? I mean, we've had the time to just DevOps the hell out of everything in some cases twice in the application area, and the databases are still off to the side somewhere. They're a parallel, separate side process where they talk about things in hours or days. That's 72-hour SLA for the ServiceNow ticket. Yay. You know, meanwhile, we got minutes or even seconds on the app side. It's kind of crazy pants. And it's not like the tool chain's really doing that much about it. Like I went and did a very informal survey of popular CI/CD orchestrators, and old ones, new ones, cloud native, classic on-prem, what have you, and the extent of their coverage where they have specific functionality pretty much boils down to, we can run that SQL script real good for you. Woo! All right, well, that's not so good. So what's going on here, right? I mean, what is it about databases that cause them to be off by themselves? Well, there's a number of things, right, as you might imagine, right? The tip of the iceberg is the technical issues. Databases, unlike applications, are by nature, by design, and everything about them sticky and stateful beasts. It's a design feature, folks. We don't want them to change or deal with or like randomly do things or kind of be ephemeral, and they're kind of too big to do that in a lot of cases. Data has a gravity. So that's number one. Number two, they sit really deep in the stack. I go, you know, again, I work the enterprise beat, and I will tell you the number one integration pattern that we see is database level integration among app systems. Many large apps, some of them being modernized with APIs so they can talk to each other and that sort of thing. Some kind of a service layer that abstracts the data being built somewhere, but the number one integration point is down there in the database. So it's kind of this beast down there, and a lot of things depend on it as a result. And let's be clear, too, that there's more than just data in these databases, right? There are these structures and logic in some cases and other things there that if you get wrong, can destroy that data that we're trying to protect. So that's a bad thing too. So by their nature, they're a little tricky. By definition, you don't simply go in there and monkey with them. Now, of course, it wouldn't be DevOps if we didn't look at the rest of the iceberg. Technology is always the tip of the thing. The scary stuff under the water, the main part of the iceberg that rips the rivets off of large steamships, is the organizational factors, right? Most organizations, most enterprises still treat the DBAs as a special deal, a special black box over here that we throw stuff over the wall to. They're like a fortified silo in a lot of cases. Meanwhile, outside of the fortified silo of DBAs, we have devs who are now empowered to be full-stack developers, right? They are vastly outnumbering the DBAs in most organizations by about 100 to 1 in my own informal survey. I've seen numbers as high as 200 developers to 1, all of whom need database changes made as part of their features from time to time. Organizations are also seeing a lot of innovation around database engines. There are database platforms coming into enterprises now that previously would have been seen as unacceptable, right? All of a sudden we see this. Plus, there's the whole NewSQL movement. Like, aside from the whole NoSQL thing, there's a whole level of NewSQL platforms coming in at new rates. And of course, you know, it's not like we're getting a lot more DBAs, right? So that's a factor. Constrains the amount of bandwidth you have to drive changes through. And management is running on about how data is now the organization's most valuable asset, right? It's the new oil that fuels the new industrial revolution in which we find ourselves. So you DBA guys better take good care of that. Yet another bit of fortification around the silo. When you put the factors together and you look at the whole iceberg, though, it starts with the fact that the penalty for failure around any of this stuff is really high. These databases are humongous in enterprises, 40, 50 terabytes, and you know, if you get something wrong there, depending on the visibility of your brand, you might be in the news because the recovery time is completely ridiculous and unacceptable. Right? So organizations have reacted with typical organizational prowess, right? If something's a little fiddly or whatnot, surround it with process, avoid changing the thing, put experts in the loop as the safety net, the circuit breaker to make sure no bad change happens. And if worse comes to worse, you can always blame them because they were the experts anyway, right? Meanwhile, you've got to deal with the fact that the database is the point of integration among all these applications. A lot of different people driving changes into it. A lot of people want changes into that database. It's very common for an application team over here to find out something they thought worked doesn't because somebody changed something from over here. And the communication and collaboration in a large organization to keep all that stuff synced, especially across geographies, time zones, and everything else, is hard. Right? We wouldn't even get into what that involves with if you want to have good test data to make sure your features work. Right? Those full-stack developers that we talked about, they are new at this whole SQL thing, right? That's a very new phenomenon. The whole notion of a full-stack developer, whatever that means, is that is very new, especially in classic enterprises. And these developers do not have great SQL skills in all cases, right? They can make something that works, but is it going to be performant? Is it going to do something that causes the database to spin for hours at a time? Well, the DBAs are there, and they serve also not just as a circuit breaker, but also as a coach. And of course, that fortified DBA silo, it's a cost center, kids. That's expensive, right? It's an operational thing. It's a cost center for the business. So we manage it. We limit access to the people in there, still referring to them as resources, of course. And we're there. And part of that, and part of the proliferation of new database platforms is due to cost cutting. We're done buying Larry Ellison's new yachts. That cheapo Postgres and MySQL stuff, bring it on. All right? So there's a lot of stuff going on there. And I mean, if you think about all these things and what the implication of this stuff really is, it looks a little daunting. Well, I got good news for you. We've dealt with this before as a DevOps community, right? These conversations that we have around this sound an awful lot like the conversations we had back in the day when we were trying to convince people that ephemeral environments were actually doable. You didn't have to have big machines that you treated like pets, right? We used to talk about server hugging and how that was a blocker and it caused things to slow down. And we got through it, right? There was no magic bullet for convincing people that that would work, right? It was about learning, it was about understanding, it was about empathy, it was about innovating, it was about trying new things, right? It's like a lot like what we're going through now as we try and persuade people that DevSecOps is a good idea. Application security built in, crazy talk, right? There's no magic bullet for taking down the monolithic architectures that are integrated at the database in these environments, right? And guys, it's kind of engineering. There's not a lot of magic bullets out there, if any. All right? We've done this before, we know how. So it's time for us to go to our respective shops and kind of get to work. Start working this problem. Figure out what it is, where the levers are in our organizations, where we can get started in moving this. Get some quick wins, measure those wins, repeat, iterate, measure, get better. Get better. All right? We can do this. We've done it before. Many times. We're doing it in other areas. It's the database's time, darn it. So what does that mean then? Well, if we're going to do this, we probably ought to know something about database change management. Right? What is it about these databases? How do I change a database? What is it? How do you even approach that? Right? I'm not a, you know, what if you're sitting there like, I'm not a DBA, what do I do? Well, good news here too, is that when you boil it all down, there are really two fundamental approaches for how you do database change management. All right? There's what's called migration-based change management, and this says that the change itself is the most important thing. It is the first-class citizen of what we're trying to do. It is a situation where you develop the scripts, you say, I'm going to make this change, and then you manage the heck out of that change through whatever qualification pipeline you have until it hits production. The other is state-based. And state-based says that the state of the database is at any given point in time in the pipeline. And each of the state of each of them is the most important thing. And I'm going to manage the heck out of the state, and I'm going to use differences between those states to generate the changes that I need to promote through the pipeline. All right? Just sort of comparing them. Migration is primarily an IaaS code-based type of an approach. State-based is more point and click. Migration requires somebody to intentionally write and develop SQL and DB engine specific code. State-based usually relies on a tool to have that knowledge and to do the right thing for whatever database you're dealing with. Migration-based, again, it's the individual. They specify specifically what will be changing. State-based, the tool discovers what should be changing. Migration-based only cares about the targeted objects. State-based, by its nature, if you think about it, cares about all the objects all the time. Now, each of these approaches has strengths and weaknesses. Right? There are good points and bad points to all of these things because, again, it's engineering. There's no magic bullet. It's a set of trade-offs that we make as we choose our approaches. Now, a migration-based approach, it makes it very easy to track the changes. This is the stuff where, you know, we have doctrine for this if you think about it, right? We have developers, we know how to take in code, we know how to merge the code. If I've got a very large database, it's very easy for me to target to specific things because at the end of the day, I'm explicitly saying what I'm going to change, right? I can take those changes that I've brought in and group them into logical, traceable things that I can move along. I can redefine them. I can pull things in, pull things out, because it's just a list of stuff I created. And if I have to do any serious refactoring or data-specific work, I can do it very natively because it's all one set of work. State-based thrives where I've got a more closed system. I've got a closed kind of a team, very few apps around a database, and I don't have very good SQL or database engine knowledge on the team. right? I'm substituting the tool in for that, right? If I have situations where I'm worried about out-of-band changes or changes I don't know about coming into my database change, StateBased is going to catch that every time because it's looking at everything all the time, right? And if I make a bunch of bulk changes to a database for some reason, it's very easy to figure out what they were and then promote them through because it's going to capture them, all right? Here's where we get to the trade-off thing, all right? Migration-based approach requires that good knowledge, that good SQL knowledge to be on the team. That can be hard to get sometimes, right? Requires that knowledge for not just creating the changes, but also how to sequence and bundle them, understand what the implications of them are as you put everything together. And you kind of have to do the DevOps thing. You absolutely can't sit in the fortified silo anymore. You actually have to tear down the wall and let the devs and DBAs work well together. And because you're only looking at what you're looking at any given point in time, if you have any worries about drift detection, you've got to go invent a process for how you're going to look for out-of-band changes and ensure that things aren't happening in the database that you might not want to have happen. StateBased struggles when you have to deal with isolating changes, merging changes, having multiple contributors creating changes and bringing them into an environment, right? We got multiple teams creating changes, got A, B, C, D, awesome. Well, which one goes first for defining the state? How do I know which one that is, right? So I have to invent a process now to arbitrate among that and resolve those conflicts. So I got to invent a process over here too, all right? Have to deal with the fact that because state matters, my database promotions and how I manage that state has to be absolutely perfect every time. Otherwise, when I promote something from A to B, if B isn't starting exactly where A was, when I started making changes there, what I promote from B to C could be different. And that's very difficult for traceability purposes. Right? So that becomes a thing. And in order to do a lot of this, you have to have somebody reviewing that bulk generated code that came out of the tool. Right? And as we all know, reviewing code generated by tools is exactly as much fun as it sounds like. Yeah. All right. So before we get into you've got to have one or the other, right? Start drawing the lines, you know, Linux and Windows, right? No, it's not like that. It's not like that at all. Key thing to take away from this is understanding both of these processes, because at the end of the day, you're going to use one as your primary. You're going to say, this is how I do it. This is the core, this is the backbone of my philosophy of how I do it. But you're going to cherry pick things from each of them at different points in your process. Right? You may be doing state-based, but you're going to need tweak scripts. That doesn't mean that those tweak scripts suddenly make you migration. Right? You still mostly state. Similarly, if I'm doing migrations, I may use state-based techniques to generate or understand my changes and make sure that everything's going to line up the way I expect it to do, or to do some QA on what I'm doing. Right? There's no purity thing here. This is engineering. You use the right techniques at the right time to solve the problem for your organization. So, thus, edified on the basics of database change management, let's talk about CI/CD, right? At the end of the day, it's DevOps days, and that implies you've got to talk about a DevOps practice or culture, or both. And we're interested in CI/CD. How do we make these changes flow quickly to support our applications and move as fast as our applications so that we can get the features we want and the value we want from the work that we're doing? Good news, folks. Just throw some example CI/CD practices up here, right? Here's the thing. All these practices that we talk about for CI/CD for our applications, they all apply. All these principles apply to doing the database changes, right? Involving everyone, right? Keeping our feedback loops short and our batches small. Right? Making sure that production-like environments are available and that we're doing things all the way through the pipeline the same way every time, so that we have a clean rehearsal when it comes time to production, and production's a non-event. Right? All completely applicable to the database. So that's good. All right, so everything you know about CI/CD is completely applicable here. The database doesn't make it weird or different. All right? Cool. So there are 4 basic things. If you're going to start down this journey, there are 4 things that you need to think through as you're designing a solution for bringing databases into the CI/CD flow. All right? You need to version everything, automate everything, test everything, and remember, these are really stateful things that we're talking about in the form of relational databases. All right, so that bit about ensuring production-like environments becomes really flippin' important. Okay? So, because we always talk about all the things in DevOps, all the things, we want to do all the things to all the things. What do we mean when we say everything? When I'm talking about this here, what do I mean? So for version everything, there are 3 things that you need to worry about primarily, right? First, version your database changes. Now, this may not sound revolutionary, and we're all friends here. I don't want to see a show of hands or anything, right? If you're like the big financial company I dealt with about a month ago, who puts their database changes in an open file share, you don't have to confess it, you just have to go home and fix it. Put your database changes in source control, for crying out loud, right? It's 2019 already, guys. Yeah, anyway, I'm mostly over it. The second thing you need to version is the groups of changes, right? So you're never going to do just like one change at a time. That'd be awesome, that'd be convenient, but the fact of the matter is that you're going to bundle them up. Right, there's going to be some amount of merging that has to happen, and you're going to promote them in groups. Those groups, and how you define them, those need to be versioned, and that version needs to be readable by people, human beings, but also the automation, so that both can work in concert to make good decisions and to get the work done consistently and repeatably over time. Same goes for the database schema itself. Whenever you look at a database schema in an automated process, you have to be able to identify exactly what version of that is, what changes are there, what you should expect to be there. And again, it needs to be human readable and automation readable so that you can actually do the things that you need to do and do them at speed. Shouldn't be any vagary there. All right? And of course, that brings us to the next piece, which is automate everything. Right? It's one of the pillars of DevOps. Right? We talked about tearing down the walls between the DBAs and developers. That's collaboration. We're going to talk about the automation pillar now. Right? Automation is key to pulling off speed in any of this stuff. Right? It gives us the consistency, it gives us the repeatability, it gives us the accuracy that we want. And we have to use it here, not just to process the changes. Right? We want to get to the point where we're able to give immediate feedback to somebody who creates a database change, just like we do a developer. There should be some kind of a ability to break the build for an inbound change and let the creator know that this is not a working thing. Right? Of course, the automated deployments that we're going to use to rehearse our production deployment, automation is always consistent. We're always going to do it the same way every time if we use the same automation all the way through. And then the third thing is I have to use heavy automation to reset my environments. Right? Because I'm putting unknown changes into a database, and databases are stateful by nature, if I break the database, I need to be able to reset it structurally and also to repopulate the test data that goes in there. It's the only way if you want to rapidly iterate through test cycles, if you want to rapidly iterate through change application, you have to solve for how are you going to quickly reset that environment so that you can have the next turn of the crank. Next opportunity for feedback. Right? Which comes into the testing everything piece of it. Not only do you need to test the changes, right? And when it comes down to testing database changes, again, there's a paradigm for this. We all know it. Right? We want to know if the inbound change is any good or is acceptable, right? Does it meet our standards? We have static code analysis for our app code, hopefully. Right? There are static code analysis tools out there for SQL. You can apply standards to it. You can go and look for things. You can screen for unacceptable commands. Right? Did the changes work? Right? If I apply them to my database, right? And by the way, you're going to need some kind of an integration database to make sure everything goes in well before you go big. Right? Did it work? And most importantly, if it worked, what's the smoke test equivalent? Right? So we got scan it for changes, compile it, smoke test it. Well, we want to inspect the database after the thing runs to know that the database was left in the expected or acceptable state for promotion to the next stage in the pipeline. And then we can get into application feature testing. Right? And that's why it becomes so important. If you think about having those high-fidelity tests and making sure I can do that, well, those environments that I reset to have to be production-like or as production-like as possible, both from a structure standpoint as well as to have appropriate test data brought in. Right? Have a doctrine for how you're going to refresh that test data and reset it. Have a strategy for if a change does break and it's something you can't reset, how is the change coming into an environment fixed? Doesn't have to be rollback. Everyone says rollback because we learned how to do that in 1989 because the British government told us it was a good thing. ITIL anyone? We also have fix forward. We've got automation. We've got new techniques. This is DevOps. We can fix forward, we can fail forward, and we can move fast. Right? There's no rule that databases can, because they're stateful, only go in one direction or the other when it comes down to a problem. All right? Absolutely core and critical to how we do this. So, to sum up, right? This is all doable, folks. We know how to do this. We have done this as a community for things that are, I would argue, at least as hard as databases as over our history, right? There are approaches out there that work. There are tools out there that work. It's completely doable. I encourage you to look into how this is being done at your shop. But be aware, just like the rest of DevOps and everything else we're going to talk about here, there's no magic bullet for the technical, cultural, and organizational dynamics that we all have to work through as we try and improve the state of play in our organizations, our environments, and our teams. Okay? So, with that, and knowing that I'm the guy standing between everyone and lunch, or y'all are the people sitting between me and lunch. All right? Just to be clear. We can also declare and. It's both until the first plate of food is served. It's kind of a Schrodinger thing. Google proved that yesterday, I guess. So we're good to go. But I do want to leave one last thing before I go, a set of resources for everybody where you can start reading up on this stuff. Read up on the core readings for the state versus migration stuff and what that really, the layers below what I've talked about, why that's all important, and a list of tools here that are out there, commercial, open source, kind of a mix, that are relevant for tackling this problem and the things that can help you hopefully move the needle when you go back and start solving for this problem. So with that, and appetites primed, thank you all very much.
Thank you.